Hello number ninjas, welcome back to my channel. Now it's time to meet the wild cousins of our number system family, and that is irrational numbers. Now what is irrational numbers? Irrational numbers are the numbers that cannot be represented in the form of p by q, right? Until now all the numbers that we have talked about, like natural numbers, whole numbers, integer or rational numbers, all these numbers can be represented in the form of p by q, right? But this number refused to be tamed, so we call this number irrational numbers. Now what is the definition of irrational numbers? A number that cannot be represented in the form of p by q, that is irrational numbers. Now if I have to give the examples of irrational numbers, here are the examples. Root 2, famous example is pi. Now 1.10, 100, 100, now these are the examples of irrational numbers, right? Now how to identify whether the number is irrational or not? So you have to look at the decimal place. We will talk about it in the next session. We will see how we can find whether the number is irrational or not. We will find irrational numbers between two numbers, right? But here you just remember that after the decimal place, if number goes on for infinite and does not repeat the same pattern, what I am saying is, here I have written three numbers. First of all, you have to see whether the number goes up to infinite after the decimal point. So for the first number, it goes up to infinite. For the second number, it does not. It stops at some point. For third number, yeah, it goes up to infinite. If the number does not goes up to infinite, that means the number is rational number. So what you have learned, if the number stops at any point, that means the number is rational numbers. You can represent this by 256 upon 1000, right? Now for this and this number, this both number goes for infinite after decimal point. Now you have to see whether the number repeats some digit or some pattern. Here you can see 3333 repeats, right? So this number is also a rational number. We will learn how to represent this type of numbers in form of p by q, right? But now for this number, here you can see 2 5 6 7 8 9 10, and it will go up to infinite. Here we didn't find any particular pattern that repeats, right? So this number is irrational number. So you just have to remember that if the number is non-terminating, terminating means this number stops here, so this number is terminating number. This both number is non-terminating number. Non-terminating and non-repeating. Non-repeating means this number repeats 333 itself. So if this number is repeating number and this number does not repeat the same pattern, so this number is non-repeating. So non-terminating and non-repeating number, it is a irrational number, right? So if you represent root 2 in the form of decimals, you will find that root 2 is non-terminating and non-repeating number. So root 2 is irrational. For the same for the pi. Computers have succeeded to find 1.24 trillion digits after the decimal points for the pi, and it does not stop there, right? So pi is also a non-terminating and non-repeating number. It is also a irrational number. Same to same for this. Here 10, 100, 1000. This number goes up to infinite. You can find as many irrational number as you want, right? Now we will see big brother of all these numbers. We have learned irrational ones, also rational ones. In the rational numbers, we have learned integers, then whole number, then natural numbers. Now, if I combine all these number together, I can say other way like if I combine all the irrational numbers and all the rational numbers together, I will get real number. What is it? Real numbers. Real numbers. That means combination of all the rational and irrational numbers. For the real number, you have to remember just two things, or combination of all the rational numbers and irrational numbers, right? So I can write real number is equal to rational numbers plus irrational numbers, right? Now when it comes to notation, for the natural number it is n, for the whole number it is w, for the integer it is z, for the rational number it is q. Now we do not have any popular notation for the irrational numbers, right? In some higher level books, some people represent it by p, but we do not have to remember this. Now for the real number, the notation is capital R. Real number is big brother of all these numbers. If I ask you all the irrational numbers are real number, it is right. If I ask you all the rational numbers are real numbers, it is right. But if I ask you, oh, any irrational number can be rational, or vice versa, any rational number can be irrational, that will be false, right? Irrational and rational numbers are both completely different things, and rational number contains all these numbers. We have learned it in the previous lecture already, right? So we got irrational numbers and rational numbers. Rational number contains integers, whole number, natural numbers, and all the numbers that can be presented by form of p by q. Irrational numbers are numbers that cannot be represented in the form of p by q. And we got real numbers, combination of all these numbers. Real number it is equal to rational numbers plus irrational number. We call it q. So if anyone asks you what to what notation can be used to present the irrational numbers, I can write r minus q. That is, if I subtract all the rational numbers from real numbers, I will get irrational numbers. That is very simple, right? You can get it from here also. For the irrational numbers, you if you put rational numbers to other side of equal to sign, you will do the negative sign. So real numbers minus rational numbers equal to irrational numbers. So we can represent it in the form of r minus q, right? So this is the basic things you have to learn. So all the numbers that we have talked about, you can see here real numbers. There is two part of real numbers. One is irrational and one is rational. There is several part comes under the rational numbers. One is integer, whole number, and natural number, right? Now we have talked about number line. This is real number line. Every point, every point of number line represents a unique real number, and same for otherwise. Every real number can be represented as a unique point in real number line. What I am trying to say is, for the every point in number line, you can represent a unique number. This point represent a unique number, unique real number. This point also represent a different real number. This point also represent a different real number, and for vice versa. If I want to represent any real number, I will find a point in number line that will represent that number, right? So that means if someone says this point does not have any number in number line, that will be false. All the point on the number lines have a unique real number, right? Now we will go to the examples. Now here is our example 3, and that is to locate root 2 on the number line, right? Now we all know that root 2 is irrational number. 3, -1, -2, -3. Now to locate root 2 on number line, I will use a Pythagoras theorem. For the right angle triangle OAB, we all know that OB square equal to OA square plus AB square. Now if the length of this side OA equal to 1 and this side AB equal to 1, so OA square equal to 1 square, AB square equal to 1 square, this will become 1 plus 1, this will become 2. So OB square equal to 2. Now if I remove square from this side, I will get square root on other side. So OB equal to root 2. So the length of this side OB will become root 2, right? I will draw the same case scenario. Here is right angle triangle, don't forget that, right? If I will use same case scenario on this number line, I will get root 2, the length of root 2, right? Now imagine this is O, is point O, right? Now I have to, the length of OA have to be 1. So length of 0 to 1 is 1. So I can write point A here. So length of OA will become 1. Now I have to I have to draw the same, I have to draw the line of same length and to be right angled, right? You can draw it easily. Length of OA equal to 1. Now length of AB is also equal to 1, and there is right angle between them. So if I connect O and B, length of OB will become root 2, right? I have to find root 2. Now we have to use a compass, put a pencil on B, a point on O, and take a measurement and make a mark on number line. And this mark represents the point root 2, right? It is very easy. You have to use Pythagoras theorem. Just draw a triangle on the number line of the sides. Here is sides O 0 1, that is length of length 1, and this side also of length 1. We will go root 2 as a hypotenuse. Now if I mark this side on the number line and this the point I get is root 2, right? For the same way, if I have to represent root 3 on the number line, and it will become our example number 4. I will do the same case. But now the length of sides will be different. So imagine if length of side OA equal to root 2, length of side AB equal to 1, what will be OB? Side OA equal to root 2, so I have to write root 2 square, AB equal to 1, so I have to write 1 square, root 2 square equal to 2, 1 square equal to 1, and this will become 3. So OB square equal to 3, so OB equal to root 3. I want to find length of root 3 also, right? So this side will become root 3. Now for the same line, distance from O to this point, it is equal to root 2 from this to this point is root 2, as we all know. Now if I draw a line of length 1, because I want to find this side of length 1, right? So length 1, and it is also right angle. If I connect these 2 points, I will name something different so we will not confuse. Here is D, here is C, O C, O C, O C, O D, C, right? So if you zoom this, you can find I have to do this. This is root 2, this is O, this is point D, this is point C, this is of length 1, this is root 2, and I will get OC equal to root 3. Now again use compass, put pencil on C, point on O, make a mark on number line. You will get this point. So this point represents root 3, right? You can also use different method that is mentioned in your textbook. That is like this is triangle of length 1 and 1, right angle root 2. If I draw a perpendicular here of length 1, for your understanding, let me use different marker. If I draw a perpendicular here of length 1, and if I connect these 2 points, now you can see for this triangle, the length of the base is root 2, same as here. The length of side is 1, same as here. So length of this side will become root 3. So you can easily measure this and make a mark on your number line, right? So this is your examples. Now we will move to the exercise 1.2. Now we will see the exercise 1.2. The first question is I have to state whether the statements are true or false, and I have to give the examples for the same. Now for the first is every irrational number is a real number. We all know the definition of real number, right? Real number contains all the irrational numbers and the rational numbers. So this weird statement is very true, right? So the first test statement is true, and I have to write the reason. So you can write real number contains all irrational and rational numbers. So the first is done. Now for the second. Every point on number line is of the form root m. The statement says this is number line. Now every point on number line is of root m. So if I take any point from the number line, right? Like I have take root the point 2. Now to represent 2, I can write root 4, right? Now to show 1, I can write root 1, right? Now to show this point 3, I can write root 9. So this statement says every point of the number line can be represented in the form of square root of a positive integer or a square root of a natural number. This is 9 is natural number, 4 is natural number, 1 is natural number. Is this statement true? The statement says that for the every point of number line. Obviously this statement is false because I have to give the example, and the example is, now let me write 2 by 3. There will be 2 by 3 on number line, and let's say here is point 2 by 3, right? Now no, the 2 by 3 will come this side, 0.66, right? So here is 2 by 3. Now for the 2 by 3, if I represent 2 by 3 in the form of square root, it will become square root of 4 by 9, and 4 by 9 is not a natural number, right? The statement says that for the every point I can write in the form of root m, where m is natural number. But for the 2 by 3, if I try to write 2 by 3 in form of square root, I get 4 by 9 under the square root, right? And 4 by 9 is not a natural number. So the statement is false. Now for the third, every real number is an irrational numbers. We all know that real number is big brother of all numbers. So I cannot say that every real number is irrational number. There are rational numbers also comes under real numbers. So rational numbers and irrational numbers are not the same. So this statement is false. And if I have to write example, let's say 2 is real number, but we all know that 2 is not irrational numbers, not irrational numbers. If the given statement is false, you have to find one example that contradict the statement and your work is done. But if the statement is true, you have to write answer in general way, right? That all the other numbers comes under your statement. Now for the second, are the square roots of all positive integers irrational? We have seen the examples of irrational number, and I have told you that root 2 is irrational, right? So this question asks, are the square roots of all positive integers are irrational numbers? We all know that root 4 equal to plus or minus 2, and that is not irrational number. So the statement is false. So we will write no. And if not, then we have to give an example that shows that square root of a positive integer is not irrational number. So here is example, root 4 equal to plus or minus 2, and that is not irrational numbers. So here is first and second question of exercise 1.2. Now we will move on to the third question, and that is to locate root 5 on number line. Now to locate root 5 on number line, remember one thing, to locate any type of square root on number line, you have to find a previous square root. Like if I have to represent root 3 on number line, I have to get one side is equal to root 2 and one side equal to 1. I have to find root 6 on number line. If I got root 5 and 1, then my work is done. If I have to find root 8, then I have to find root 7 and 1. So if I have to find root 5 on number line, one side of my triangle will become root 4. And we all know that root 4 equal to 2. Let me write root 4 for your better understanding. Now one side will always become 1, one side will become root 4 OAB. Now according to Pythagoras theorem, OB square, I will write directly uh, root 4 square plus 1 square. This will become 4 plus 1, this will become 5. So OB equal to square root 5. This will become square root of 5. Now to represent on number line, here is 0, 1, 2, minus 1, minus 2. Now this side become of length 2. So 0, 0 to 2, I name this point O, name this point A, length of this side become 2. Now if I draw a perpendicular here of length 1, length 1 means from point 0 to 1, right? And if I name this point B, now if I connect these two dots, length of OB will become root 5. Now you have to put pencil on B and point O for your compass on O. Now measure this length and make arc on a number line. You will get point root 5. Just represent it, yes. So it is very easy. Now for the next part, we will see how to represent decimals, right? How to represent decimals in the form of P by Q and theory of terminating and non-terminating digits, how to find irrational number between 2 points and all this stuff, and also next exercise 1.3. So thank you for watching this video. We will see you in the next lecture. Stay tuned.